So in this video, we're going to learn how to multiply complex numbers. So we can multiply an imaginary number by a complex number using strategies that we learned when multiplying polynomials. Remember how we multiplied a polynomial by a monomial using the distributive property. For example, if we have 2x times 3x squared plus 2x plus 1, we took that 2x and multiplied it by every term in the polynomial. That gave us 2x times 3x squared, which is 6x cubed, 2x times 2x, which is 4x squared, and 2x times 1, which is 2x. We leave all of these terms separated by a plus sign because these are all unlike terms and we cannot combine them. So if we're using this strategy, we can multiply a complex number by an imaginary number. Always remember that we can simplify even further by using the fact that I squared is equal to -1. So for example, if we have 3i times 7 minus 4i, we do 3i times 7, so 3i times 7 gives me 21i. Then we do 3i times 4i, which gives us 3i times 4i, which is 12i squared. So here, basically, I have 21i minus 12 times I squared, which is -1. So we have 21i minus -12. Well, minus negative becomes plus, so we have 21i and 12. And when we rearrange that to be in standard form, we have 12 plus 21i. So you can also multiply complex numbers using your graphing calculator. So if we want to do this problem right here, we do 3 and then remember second and then the decimal button to get I. And then we do parentheses 7 minus 4 and then second the decimal button and then we hit enter and we get 12 plus 21i. So let's try now multiplying 5i times 2 minus 3i. So remember, we're going to distribute that imaginary number to every term in the complex number. So we have 5i times 2 minus 5i times 3i. So 5i times 2 is going to be 10i, and then we have minus, well, 5 times 3 is going to be 15, and then I times I is going to be I squared. So 10i minus 15 times I squared, well, that's 15 times -1. So that's going to be 10i minus -15. Minus negative becomes plus, and remember we need to rearrange this to be in standard form, so we have 15 plus 10i as our final answer. So let's make sure that this is correct using our calculator. So we're going to do 5i parentheses 2 minus 3i. And when we hit enter, you can see it gives us 15 plus 10i. So now you can go ahead and pause the video and try doing this example on your own. So we do 2i times 6 plus 2i times 5i, which gives us 12i times 10i squared. That's 12i plus 10 times -1, which is 12i minus 10. So that, when we rearrange in standard form, is -10 plus 12i. We can also double check this on our calculator. So we do 2i parentheses 6 plus 5i, and when we hit enter, it gives us -10 plus 12i. So we can also multiply complex numbers together using the strategies we used when multiplying polynomials. So remember, we used FOIL because remember, a complex number is kind of like a binomial because we have two terms in it. So remember, F stands for first, so we do 2x times 3x, which is 6x squared. O stands for outside, so we do 2x times 1, which is 2x. I is inside, so we do -3 times 3x, which is -9x. Last is -3 times 1, so that's -3. Remember, in the final step, we add up all the terms, and if we have any like terms, we combine them. Here, the 2x and minus 9x are like terms, so we get 6x squared minus 7x minus 3. So when we multiply complex numbers, remember, we always want to keep in mind the fact that I squared equals -1. So first, it's going to be 3 times 2, which is 6. Outside will be 3 times -5i, which is going to give us -15i. Inside is going to be 4i times 2, which is equal to 8i. And last, we have 4i times -5i. Well, that's going to give us -20i squared. -20i squared is basically -20 times -1, which is +20. Notice that now when we add up all our terms, we have 6 minus 15i plus 8i plus 20. Well, we can combine now our like terms because -15i plus 8i is going to be -7i. And then we have 6 and 20 that are also like terms, so that gives us 26 minus 7i. Remember, you can always use your graphing calculator to do these problems also. So if we do 3 plus 4i times 2 minus 5i, We get the same answer, 26 minus 7i. So now let's try this example. So we have negative 2 plus 7i times 5 minus 2i. So I'm going to use FOIL and then I'm going to check my answer using the calculator. So first times first is negative 2 times 5, which is negative 10. Outside is going to be negative 2 times negative 2i. So that's going to give me 4i. Inside is going to be 7i times 5, which is going to be 35i. Last will be 7i times negative 2i. And so that's going to give me 7 times negative 2, which is negative 14, and then I times I, which is I squared. Well, remember, I squared is negative 1, so we have negative 14 times negative 1. Negative 14 times negative 1 is positive 14. So now let's add up all our terms. So when we add up all our terms, I like to use a shortcut, and I just figure out the like terms as I'm doing it. So for example, I have negative 10 as my first term, but then I know the like term that'll combine with it is 14. So I'm going to go ahead and write them together. And then I have 4i, and finally I have plus 35i. So writing the like terms together just kind of helps me get one step ahead of this process. So negative 10 plus 14 is going to give me positive 4, and then I have plus 4i plus 35i, which is 39i. Remember, you can always use your calculator to multiply also, right? We can do negative 2 plus 7i, and then times 5 minus 2i, and when we hit enter, that gives us 4 plus 39i. So now you can go ahead and pause the video and try doing this example on your own. So we have negative 3 plus 2i times 2 minus 4i. Negative 3 times 2 is negative 6. Outside is negative 3 times negative 4i, which is positive 12i. Inside is 2i times 2, which is 4i. Last is going to be 2i times negative 4i. So when we multiply that, we get negative 8i squared. Negative 8 and times negative 1 is going to be 8. So when we add up our terms, we have negative 6 plus 8, which gives us 2. Then we have 12i plus 4i, which is going to give us 16i. Remember, you can always use your calculator. You have negative 3 plus 2i times 2 minus 4i. And when we hit enter, you get 2 plus 16i. So I want to show you that we can also use this if we're squaring a complex number, right? Because I know when we're squaring, it doesn't look like we're multiplying, but that is what we're doing, right? Because we're doing 2 minus 3i times 2 minus 3i. You can think of it this way. So when we do this, we can do it one of two ways. You can use that perfect square trinomials pattern. Remember, we have that a minus b squared equals a squared minus 2ab plus b squared. Because in this case, a is going to be 2 and b is going to be 3i. So what we can do is we can write this as 2 squared minus 2 times 3i plus b squared, so 3i squared. 2 squared is going to be 4 minus 2 times 2 is 4. 4 times 3 is 12. So 4 minus 12i plus 3i squared. Well, 3i squared, I'm going to square both these terms. 3 squared is 9, so I have 9i squared. So we have 4 minus 12i and then plus 9i squared. Well, that's 9 times negative 1. So we have 4 minus 12i minus 9. Well, 4 and minus 9 combined, so we have negative 5 minus 12i. So you can get the same result also if you do FOIL. So if we do first times first, 2 times 2 is going to give me 4. Outside, we have 2 times negative 3i, so that's going to be negative 6i. Inside is going to be negative 3i times 2, which is negative 6i again. And then last, we have negative 3i times negative 3i. Well, that's going to be 9i squared. 9i squared, we already saw, was 9 times negative 1, which is negative 9. When we add up all our terms, we have 4 plus negative 9, right? Because those are our constant terms. And then we have minus 6i and minus 6i. When you combine these, 4 minus 9 gives me negative 5. Minus 6i gives me minus 12i. So same answer. A third way to solve this problem is to just type it into your calculator. You can do 2 minus 3i squared. And when you hit enter, it gives you negative 5 minus 12i. So there you go. You have three ways of squaring a complex number. So remember, you can multiply a complex number by an imaginary number or a complex number by a complex number using techniques similar to those we used when multiplying polynomials. You can also use a calculator to solve these problems.